Hi, welcome to the Byrne-Wheeler Report. We're recording this on the 19th of December, 2025. On today's show, we're going to talk about Anthropic being revealed as the TPU customer, startup Tsavorite somewhat coming out of stealth and intimating that it's providing a GPU alternative for AI processing. Marvell disclosed a switch roadmap at its recent analyst day. Qualcomm is acquiring RISC-V startup Ventana and has just closed its AlphaWave acquisition. And we'll see what else comes up in our discussion. With that, Bob, how are you? It was good seeing you last week.
I'm good, Joe. I'm finally not coughing anymore. So
Yeah, you sound much healthier. So in our last episode, in between the sniffles, we were talking about, there had been reports that Meta was going to be the customer of Google TPUs with Google supplying actual hardware instead of renting cloud services. And subsequently, it's been revealed that Anthropic is the customer. I think it was Broadcom that spilled the beans about that, right?
yeah, that's correct. It came out in Broadcom's earnings call that the previously announced customer for a $10 billion order for AI rack systems, by the way, was in fact Anthropic, and those racks are Google TPU racks. And then there was a subsequent $11 billion order, so it brings the total to $21 billion supplied via Broadcom.
Right. And were those two orders both for Anthropic, or is there a second customer in the offering?
No, same customer, so those are both Anthropic.
Yeah, so it's interesting. Anthropic hasn't run its own data centers. It's been mostly working with Amazon and running some workloads on Trainium. It's also worked with Azure using Nvidia, and there have been some models hosted at Google on the TPU, and now it's investing in data centers that will basically own versus rent. Any thoughts about that?
Yeah, I mean, I guess it's not total. There's a few things that aren't totally clear yet. One is where these racks will actually end up physically, what data center they'll be deployed in. The other thing that's kind of interesting is that to do the kind of the full TPU pod, you also need the optical circuit switch.
Right.
It's not
do the right. They can connect via copper to adjacent TPUs, can talk to adjacent TPUs over copper, but to do the sort of the highly interconnected approach, they need that optical circuit switch.
Yeah,
right?
for the pod scale, and so it's not really clear. Does Google really want to be supplying OCSs? Are they supplying those through some third party? That piece is an unknown, and it's quite interesting, separate from just the use of the Google TPUs.
Yeah, because these optical circuit switches aren't off the shelf or even adapted from off the shelf components, right? They're totally
it's a custom Google system.
As for the whereabouts, my understanding is they're working with NeoCloud company FluidStack, which had stated that they're building a data center in New York and one somewhere else in the US. And I think if I was just piecing this together today, so there was a disclosure article report, I guess, maybe not a disclosure per se, but a report that in September that FluidStack was going to be getting TPUs. And that was back in September. And then subsequently there was a real disclosure that FluidStack was going to work with Anthropic. So we probably could have put the pieces together sooner had we had them all laid out in front of us.
You can connect the dots after the fact, yeah.
Yeah, after the fact, because a lot of these are just, it's reports, but not official disclosures. And, unless I heard it from the source myself, I understand it's very easy to get wires crossed, and there's a bit of a game of telephone that gets played. But I think the key point is Google is supplying TPUs, or let's say TPU-based racks or pods, and they're emerging as a strong alternative beyond like kind of this internal use, but alternative for other companies looking to buy equipment.
Yeah, and I guess the other piece from a business perspective is, who knows how they actually divide the kind of the margin between the contract manufacturers that are actually building the systems. I mean, there's a lot of pieces in the value chain there, and not clear what kind of margin Broadcom would ultimately net in this situation.
Right. I mean, Broadcom is very focused on making money. The days of companies kind of seeding some profitability in the short run in the hope that things will change in the long run or along behind us. Broadcom was one of the first companies, I think, to show a lot more financial discipline. Our second item, startup Tsavorite, came out of stealth mode somewhat. They have experienced leadership in designing big chips, and also they were at the startup that created the CXL chip that Marvell acquired that business, and that became their Structera product. They didn't disclose too many technical details, but they did disclose a few. And I think the most significant and impressive thing is they say they have $100 million in orders, which for a startup that still has some time to go before it has a chip that it can ship production quantities of, that sounds like a lot to me.
Yeah, it's a little unusual. They're not talking about their funding. They're talking about their actual orders, which is, in a sense, refreshing after watching the amount of money some of these companies have raised with zero revenue.
Right. Yeah, agreed. And it's kind of curious also. We've had a few companies, whether it's GraphCore or Esperanto or whomever, some startups that have gone under, to still have startups piling in, even as, the market's as competitive as ever, with Nvidia proprietary solutions, AMD, Google branching out. So they're entering into a tough business.
Yeah, I mean, I guess, in terms of their sort of high-level story, a couple of things that jumped out at me. One that's probably most important is that CUDA compatibility was a primary focus for them. So they really did the compiler first in their design, RTL later. They really focused on software compatibility. Now, it's, easy to say, maybe not so easy to deliver, but anyway, it's a little different from most other startups, I would say, that I've seen. And then the other thing, which is a little bit hard to believe at this early stage, is they're claiming superlinear scaling, which
right
gets them
go on.
Which gets them some kind of crazy claimed performance numbers at scale.
Yeah, although when I talk to them, the superlinear scaling example is going from 1 to 8 chips versus, 8,000. So I think what the situation is that, so their architecture, they didn't go into a lot of details, but it involves a shared address space with distributed cache, distributed computing resources, all connected by a fabric. And I think when you go from 1 to 8, you're presenting, you can think of it as presenting the workload with more resources to pick and choose from. And so you could kind of like statistical multiplex competing aspects of the workload better when you've got a larger pool of resources to draw on. I mean, I don't think there's really any way you can be super linear past kind of a small number. It's just not really the way the world works, is it?
Yeah, exactly. Yeah, they have this fabric that they branded multiplexus, which kind of scales from chiplets to chip, and then at the rack scale, and they haven't described the details of that. But I mean, that seems to be from a hardware perspective, probably their biggest differentiation is the fabric architecture. I'm intrigued to learn more there.
Yeah, and I think the distributed memory associated with that, so that my guess is like a processing resource can access a far piece of memory relatively easy versus in kind of a GPU regime, you might have to do an explicit pushing the memory over the network or pushing it like into HBM or pulling it out of HBM, putting it on a network, pulling it to the next GPU and putting it into HBM again and pulling it back. There may be the ability to streamline memory transfers and to obviate a lot of those should improve the compute utilization relative to the memory transfers. And that would give you a big speed up.
Yep. So we'll see. I mean, I guess the thing I like least about the initial pitch is the breadth of use cases they're going after, from basically edge to data center scale. To me, they're trying to target too much market breadth to actually deliver products, but I guess we'll see where they actually have the traction.
We'll see. I mean, I think some of that is their chiplet architecture. They have two different chiplets. One is oriented more around memory accesses, and one's more oriented around compute, although kind of both elements are present in both chiplets. And so they can scale down a chip by using only one type of chiplet because it can operate standalone, or they can scale up and use a few of those and then like one of the other types. It's maybe in some ways it reflects lack of focus on the market side, but I think from the technology perspective, it's more of a proof point that they've built this building block in this fabric that can scale across chiplets, and they can they can assemble the blocks together to any given size. I think maybe that's an optimistic way of interpreting what they're doing.
Yeah. So, I mean, obviously they'll follow the customers and we'll see where they actually have the traction here. As you said, they have orders in the pipeline. So those I'm sure map to specific products here.
Right. And then I would say I had two more points to make. One is regarding the CUDA compatibility. I would not expect it to be like out of the box. All CUDA code will run directly. It's more of a path to get CUDA code from running natively to kind of a streamlined way of adapting it to run on this other chip. I think there's just too much that's different between the architectures that everything is going to map 100% cleanly without some intervention. Moreover, CUDA is really big. They probably didn't implement every little library and every function built into it, just kind of find the hot ones.
Yep.
I was going to say a second point. So using ARM CPUs, where just about everybody else has been all RISC-V based. I think part of the idea is, everyone talks about agentic AI now, but what that really means is there are tools or web browsers, like curl, which is kind of the command line version, or other tools, something to build like a PowerPoint deck. Those are general purpose CPU workloads. And my guess is they wanted something fairly standard if their pitch is to attract customers to write code on the CPU side. They wanted to make it as standard as they could.
Yeah, I mean, it's certainly a flexible architecture, but we'll see if it can actually deliver on power performance. That's key.
Power performance and actually being able to run the various the various models, any proprietary training regimes that a company might have. There's a lot that has to be done right. And then the other thing I see at the edge, AI, for the smaller systems, is there's like AI is moving so fast, it's really hard for a startup just to kind of keep up with every new innovation in terms of, all right, we now have to support this activation, the models are now working this way. It's a fast-moving market, and it's just really hard to keep up with the pace that companies like Nvidia are setting.
Yeah, and I mean they have on the order of 100 people, so they are very much a startup.
Okay, and then the next thing on our agenda was Marvell at the company's Analyst Day disclosed a switch roadmap. Marvell is well known for Ethernet switches, but talked about a couple other things, didn't it, Bob?
Yeah, so I guess so just to clarify, this is their industry analyst day, not a financial analyst day. And they've been doing these for a few years now, but what was refreshing this year was they did have more kind of technical speakers, not just sort of product line VPs. And also they did reveal some roadmap information. I guess first on the Ethernet switch side of the world, I mean, we'd been waiting for any news on a 102T switch follow-on, given that they're shipping their Terralinx 10. And so they did disclose that they're going to be sampling a 102T Ethernet switch in first half of next year. the slide showed it being in production in 2026. So they disclosed this 2T switch, which realistically won't be in production until 2027. So they're probably roughly a year behind Broadcom's Tomahawk 6, but at least now they've put a marker out there that they have a product and it's coming soon. And then they actually showed a roadmap beyond that.
Hasn't that been an issue for them, that they've been coming to market with their switches just a little bit too late to get significant traction?
Well, sort of yes and no. They've been late relative to Broadcom, but their story would be that they're in alignment with the needs of their lead customer, which is Amazon. So I think as long as they are able to hold on to Amazon, they're doing pretty well. And thus far, that seems to be the strategy. So, but yes, they're late relative to both Broadcom and Nvidia for the 1T generation.
But is anybody buying Nvidia switch silicon separate from Nvidia GPUs?
Well, now Cisco has a box designed around Nvidia Spectrum X silicon. So the answer is now yes.
And will those boxes be used separate from Nvidia? Like, is that going to customers not using Nvidia GPUs?
Well, no. In that sense, it's still part of the Nvidia solution, but it's a system supplied by Cisco.
Right. So, I mean, I think okay, maybe we're rat holing here, but it seems like if they want to get past Amazon, they really need to be at parity with Broadcom in terms of timing of similar products.
Yeah, I mean, for example, Meta now has 3 different versions of MiniPack 3, which is their 51T switch. They have a Broadcom version, an Nvidia version, and a Cisco version. So, yeah, Marvell's kind of on the outside looking in on that one. But anyway, they at least showed a roadmap for multiple generations, including 400 gig per lane switches coming kind of in the 2027 timeframe. And then kind of switching gears to the scale-up side of the world. A year ago, it seemed like they were addressing the scale-up switch opportunity through semi-custom products. But then this year, they showed a roadmap for specific products for both UALink and scale-up Ethernet, or ESUN, as it's now called within the OCP. And the first UALink product is scheduled to sample in the second half of 2026.
Right. And speaking of Amazon, and past episodes, we talked about how Trainium would use both NVLink and UALink. So they could have some immediate customer pull for those scale-up switches.
Yeah, they're competing with Astera Labs that seems to have sort of the current generation design. So it would be a question of displacing Astera at Amazon.
Right. Okay. Anything else on this side to talk about?
No, obviously a lot of the excitement at the Analyst Day was regarding the Celestial AI acquisition, which we discussed, I think, in our last episode.
Right. I think maybe they had disclosed this before, but I hadn't heard it. They gave numbers, and they think it's going to generate, 500 million next year and then $1 billion in 2027 in revenue. So, you're wondering why someone would drop a few billion on a little startup with an obscure technology. Well, if they have visibility into that much revenue, it comes pretty easy to justify, particularly if it's for a customer that they're supplying other components for, and they want to kind of keep that ball rolling.
Yeah, absolutely. And I think they have to continue to differentiate their overall offering from just being kind of pigeonholed as an ASIC supplier.
Let's turn to our next news item. Qualcomm acquiring Ventana. Ventana was one of the first, if not the very first, to make a server class RISC-V cores, and they developed a couple of generations of these. I think on balance they were too early. There are now several companies offering high-end RISC-V CPUs, and at the same time, it's not clear anyone's buying them yet, but I think as we discussed previously, I think it was episode 3, we talked after the RISC-V summit. I think we're on the cusp of some of the hyperscalers, maybe some others using RISC-V in server class systems.
Yeah, I have to say it's been quite a while since I talked to Ventana, but wasn't their original story really about being a chiplet supplier?
Yeah, initially their main thrust was to make chiplets for, and it sounded like they had a particular customer that I think was in the networking space, a well-known San Jose-based networking company. But they always said that they would also supply IP and license that out, and then of course somebody could relatively easily like adapt a chiplet to build a whole server processor. They would just need the I/O chiplet to go with it.
Yeah, and I think they had kind of a reference design for an I/O chiplet as well.
Yeah, if I recall, I think they did. They've also been very active in RISC-V working groups. I mean, so Qualcomm has been active as well, but I think Ventana's been a bigger participant.
So, what do you make of the acquisition then? How does Ventana fit into Qualcomm's overall strategy?
Qualcomm has its own CPU design team. They've productized their Orion ARM compatible processors. They've been active in RISC-V. I'm quite confident they could create high-end RISC-V CPUs on their own. I think what Ventana brings is additional resources. So in that way, it could be thought of as an acqui-hire. And whether they continue with the Ventana design or use these folks to adapt the Orion microarchitecture, I think it's just going to be additive to Qualcomm. And I think it also speaks to us being on the cusp of customers, like somebody major out there wants a RISC-V chip and Qualcomm wants to compete for that.
So, do you see Ventana fitting into the broader picture of Qualcomm's kind of increasing investment in the data center space as evidenced by the AlphaWave acquisition?
Yes, I do. AlphaWave gave them SerDes and resources to do custom chips, right? And so one of these custom chips could be a RISC-V, like a RISC-V server processor. And so they would have a need to enlarge their RISC-V design team and make sure that they have a CPU that could be used in such a design. So I think it's all pointing in that direction. Because I specifically don't expect at this point merchant RISC-V chips, particularly with the Qualcomm versus ARM dispute mostly resolving in Qualcomm's favor. What I mean is, I don't think we'll see merchant RISC-V server chips, and I think the pressure to change architectures on the smartphone side is a lot less. Pictures if you don't have to.
I guess the big open question for me with AlphaWave is, they announced standard products, standard PHYs or DSPs earlier this year, so it'll be interesting to see what Qualcomm does with those.
Agreed. Although Marvell made a pretty good case for not only do you want to try to win some of the bigger chips, but also try to win some of the collateral chips around the big silicon pieces. DSP-based PHYs would fall into that category.
Correct. And yeah, they're high value, high margin items for sure.
Right. And it would certainly help their competitiveness vis-a-vis Broadcom and Marvell. With that, thanks everyone for joining us. Please join us for our next episode.
It's all about the pendients, baby.